Hey, what's up everybody, and welcome to today's webinar. We're going to be talking about cloud-based sculpting. So this is a really exciting topic. It's really fun to use and demonstrate. So I'm looking forward to showing you guys what this is all about. I'll do a real quick introduction, and by real quick introduction, I mean, hey, my name's Jared. I'm one of the application experts over here at MLC. Enough about me. For those of you who aren't exceedingly familiar with MLC CAD systems, we've been around for about 40 years or so, which is just an incredible amount of time, especially for a technology company. But I think that really speaks volumes to the type of company that MLC is. We've also got a really prominent technical team. We take a lot of pride in our technical team and trying to stay up to date with everything. And this is where we operate, right? So we're pretty big geographically. You can see that we're kind of concentrated in the south, southeast, with offices all throughout those territories that you see there. And then our CAM team even reaches all the way up into the Pacific Northwest. But hopefully you've got the experience working with us in the past. If not, we look forward to working with you, and hopefully we can provide that level of unbeatable service that is our motto. So. All right, so once again, we're going to be talking about cloud-based sculpting and using a particular application called xShape. Now, xShape is part of the X family of apps, and what I mean by that is that all of these applications you're looking at on my screen right now are able to be run in a browser, so they all are browser-based. You don't have to do any type of local install ever. You never have to mess around with updates, and you can run it on any device, even if it's a Mac or an iPhone or something. You can run it if it's connected to the internet. So super cool stuff, really exciting new technology that we're working with right here. I'm not going to go into a whole bunch of detail on all of these other X apps that we're looking at right here, but as you would imagine, sheet metal would allow you to do sheet metal design in a browser. Xmold allows you to crank out mold cavities and cores for your injection molded parts very rapidly. Xframe is like using weldments in a browser. Xdocument allows you to create MBD, or model-based definition style documentation of your designs. And then XDesign is the parametric modeler. So a lot of those, like you're probably pretty familiar with that design functionality, should I say, if you've been designing inside of Solidworks for quite a while. But something that's kind of really new to a lot of users is xShape, and this allows you to do that really cool style of organic shape modeling. And the best analogy that I can think of, right, for this application is it's like working with virtual clay. You can drop that clay onto your screen, and then you can push and pull it and manipulate it until you get the shape you want. And it's really fun, really quick and easy to learn. So yeah, that's what we're going to be looking at for today's webinar. Now, for those of you who were with us for the SolidWorks rollouts for this year, that submarine that we're looking at probably is pretty familiar to you. That's the Nemo submersible is what that is. And I want to ask everyone a question here. How long do you think it would take to model up the general shape of that body? I'm not talking all the finishing details, just the general shape of that body of the Nemo submersible. I want you to really think about that. Using conventional surface modeling techniques, how long would that take? And the answer is, I mean, it could, if you're really proficient at it, maybe a half a day to get something that looks like that. You know, I don't know, maybe you're lightning fast and you can do it in a few hours. But the truth is, it's going to take quite a bit of time to get a surface model that looks that nice. And we're going to do that using xShape over the course of this webinar. It's going to take about 20-25 minutes, something like that. So really cool, really powerful tool that we're going to be showcasing here. So yeah, let's go ahead. We're going to jump right into xShape now. So what we're looking at here is the frame of the Nemo submarine, right? And these files, by the way, were all designed inside of SolidWorks. So check this out. That's all SolidWorks files, and they were just very easily imported into xShape, so I can use them as a reference as I model up the body. And the reason we're able to do this is because this is all saved to the 3DEXPERIENCE platform. So SolidWorks was kind of taking advantage of those built-in data management types of capabilities. Maybe you caught our webinar on SolidWorks cloud data management on the platform. If not, definitely take a look at that one. So what I'm going to do here, I'm going to jump into this Nemo body shape file that I'm going to be working in. And what I want to do here, I'm actually going to turn on some hand sketches that we've already created. And these are just going to kind of give me a little bit of a guide so that as I'm doing my modeling, I can kind of push stuff into the appropriate general locations. So I'm going to go ahead, I'll grab this little box, primitive is what they're called, and I'm just going to drop that right into position. Now, just like when you're working with splines inside of SolidWorks, it's oftentimes beneficial for you to kind of take advantage of simplifying things before, and then add complexity as you're moving along. So I'm going to reduce the number of subdivided faces that we're working with right here before I drop that in. And the way that you work with this is what you're going to do is you're going to manipulate the shape and faces and vertices. You can push and pull on all of these things utilizing this robot. If you see the arrows that are kind of going in both of those up and to the right directions. So that's what we're going to use to push and pull this thing. And the cool thing about this is that the shape is going to move relative to the robot where it's positioned. So what that means is that if I move this all the way over here to the left, the shape is going to move relative to that positioning. So that allows me to be really precise with how I'm going to move this thing around. Just gives me a lot of flexibility, right? Now, by default, the faces on this shape that I'm working with have what's called a C2 level of continuity, which is great for any type of consumer design application. But one of the things you might want to do is, well, maybe you want some harder edges, and you're perfectly capable of doing that. You can select whatever edges you want to crease, is what we call it, and you can make those to where they're a sharp edge. And you can even modify this to where you're controlling the level of the crease and how sharp of an edge you actually want to have there. So this stuff works pretty nicely. Allows you to exert a lot of control over what this end shape is going to look like. All right, so that's looking good. Let's go back to that side view. And one of the things we want to do, we want to kind of taper this shape down to where it more closely matches the sketch that's behind it. So check this out. All you have to do in this case is do a box selection of all of these vertices, and then we have the ability to sketch an entity, and those vertices are going to snap to it. So let's see if I can make this look nice. Yeah, that looks pretty good, and just I want everybody to pay attention to how easy that was to do. Of course, whenever you're working on a tablet or something like that, it's even more fun because you're able to really get very accurate instead of what I'm doing is just using my mouse. So what I want to do now, I want to make this lower little front left corner kind of match more closely with the sketch view. So I'll just do a quick box select, drag it into position. We'll rotate around to our front view, and you can see how everything's sort of centered right here. Whenever I drop that in initially, it just kind of stayed centered. So I'm going to select all of the entities, doing a Control-A, and then just drag that into position to where it more closely matches my sketch image. And then I'll just select those left sides, drag that into shape. All right, so we're looking pretty good right here. Let's rotate into more of a top view now, and I can kind of take advantage of that top sketch that I have and do a little box select for that as well. All right, so this is just kind of getting things into position here. And you might notice like we're not really being exact whenever we're translating any of these entities, but we do have the capability to be very precise if we need to be. So as an example, I'll drag the robot onto this edge to where it's going to align itself to how that edge is oriented. Maybe I can zoom in a little bit so y'all can see a little bit more clearly. But what this is going to allow us to do is to move along the direction of that edge. So this just gives me some additional control. I can also snap to this nice little ruler that pops up, and I can pull for a particular dimensional amount. So you can be precise with your translations here as well if you need to be. All right, now one of the things that I'm sure a lot of folks do whenever they're modeling something up in SolidWorks or any other CAD platform for that matter is maintain symmetry, right? And we can definitely do that. Before I show you guys the symmetry command here, though, what I'll do is I'll add a little bit more virtual clay onto that top face. We can do that from the context toolbar. It's just a simple pick, and then it just slaps some additional virtual clay to work with, just like that. All right, so now that I have that in position, I'll go ahead and I'll grab these two little faces, and what I'm going to do is just drag that across to where it's over my plane of symmetry. And to do that, I'm going to change this robot up to where I'm just using the translation in the XYZ main directions. So I'll pull that across like this. Now check this out. All I have to do now is select whatever plane I want the symmetry to take place on, and then toggle on the symmetry from that little context toolbar. Now any of the changes that I make on this side are going to automatically be replicated to that other side. So really nice tool to be able to use and immediately visualize all of these changes that you're making. What I'm going to do next, if you haven't noticed, there are a lot of picks and clicks whenever you're trying to select these vertices. Fortunately, xShape gives us shortcuts that we can use. For instance, I'm holding down Shift right now, and if I select this other edge down here, it's going to select all the ones that are also in between. So there are quite a few built-in little shortcuts that work quite nice whenever you're modeling something here in xShape. I'm going to come in and increase a few of these edges here, just to kind of give my shape some more contours, kind of make it a little bit more visually appealing the way I want it to look. And you can see how with this little slider we can control the total amount of, or how hard we want that crease to be. In this case, I'm going to crease that pretty hard, and I think that looks pretty nice from here. Now what we've got to do next is kind of get this top portion of our shape aligned with the sketch that's behind it. And this next tool I'll show you is really cool. It allows us to just basically box select those entities and then use this align entities by line, which gives us a line that we can drag around, and then those entities are just going to snap into position for us. So I can kind of really quickly position things using this tool. So this looks a little bit nicer. This will snap and it'll be kind of a nice horizontal style, or at least it would have been horizontal if I'd have released at the right spot. There we go. That looks a little bit nicer. I'll go ahead and we'll roll with that. I'm going to rotate around to the front view, and now we'll just kind of get this into position to where it matches that front outline now. All right, so cool. So this is really starting to kind of come together. Looks pretty nice in my opinion, not to kind of pat myself on the back or anything. But so check this out. Like I said when we first started this, I was like, man, we want to keep things relatively simple whenever we're starting, and then we'll add complexity as needed after the fact. So this is an instance where I might want to add some additional loops to give me some more information that I can select from. And we can do that on the fly, and I can even choose how many loops I want to place at any particular time. So this just gives me additional faces that I can select from, and yeah, just you can add the complexity kind of as needed as you're moving along with all this. I'm going to crease a few more of these edges just to kind of make this look a little bit nicer here. And rotate around to this area. Let's snap to a side view, and I might do one more of these. I think that'll look pretty good here. All right. So this is really starting to kind of come together here. I might just select this edge now and drag that into position more. All right, cool deal. So this is looking good. Well, let's switch around to that front view now, and we can make one more little adjustment to that vertex we were working with. I'll just drag that over. It gives it more of a gradual transition. I think that looks a little bit better. All right, now a little while ago we added an additional loop, and I used the menu bar down here at the bottom. Well, I'm happy to announce that you can also do this from the context toolbar. Kind of saves you a little bit of mouse travel and lets you just drop that information in. Of course, our symmetry is turned on right now, so that copies that additional loop over there to the other side. Now, when it comes time to making a hole inside of our sub-D model, like you can see from our front sketch, we want to incorporate a little hole in that area. Well, how do you do that? How do you go about doing this kind of stuff? Well, cool little shortcut you can use is to select two opposing faces. And then what you can do is use that same extrude command, and it's going to pop in a hole that's going to go between those two faces. So pretty cool little deal that's going on right there. I'll go ahead and I'll toggle my symmetry back on just to kind of copy all that stuff over to the other side. And we'll kind of just let it run. Whoop, sorry, I hit the flip direction. We'll go ahead and confirm that. And there's our hole, just kind of popped in right where it needs to be. Of course, this actually matches up pretty nicely. If we needed to, we could make adjustments to that hole size though. All right, so let's see what this looks like. I'm going to get out of this subdivisional command, and what's going to happen in the background is that all these faces are getting knit together, and it's going to be a perfect, unbroken, watertight C2 continuous surface. So pretty cool stuff, right? Now, I'll go ahead and I'll save this. Remember, we're working in a cloud environment right now, and because all of this is connected with the 3DEXPERIENCE platform, I can actually import this stuff and bring it into my existing Solidworks type of workflow. So let's see how that looks here up next. I'll flip over into my Solidworks screen now. And what we're looking at is the exact same frame assembly that we were looking at in xShape, right? So this is all saved to the same platform, so we can very easily integrate these things into workflows like this. So check this out. I want to go find that Nemo body shape assembly that we were working in xShape. That way I can import it directly into my SolidWorks model. So I'm going to run a search. And this is searching my entire database that I have, and that took what, 3-4 seconds maybe? So it happens really, really quickly. I'm going to go ahead and I'm going to drag in this little body shape assembly, drag and drop type of functionality directly within my SolidWorks assembly. So pretty cool. This is the same file that I was working with, right? Now, when it comes time to mate this thing, since I'm using a similar coordinate system, I'm just going to go ahead and pop them in like this. And we can kind of get a good idea of how all of this is going to fit together. Now, in our case, I'm going to go ahead and turn this transparent so I can kind of see what's going on. In our case, what I might want to do is incorporate some little channels for these thrusters, to be able to actually function. I also might want to come in and modify the top portion here to where the hatch will have an opening to get out of. So in my case right now, I'm working independently, like I'm working with my own file set, but that's not the case with most companies. In most companies, you're working in some type of a collaborative environment, right? So what you can do, if you are working in that collaborative type of environment, I can come in and open up a preview of this file. This is all happening directly inside of my task pane inside of SolidWorks, right? Let this thing load up for me. And what I can do is I can drop in notes and then publish it to a community to where other people can see this, right? So let's see. I know there's some changes that are going to need to be made, so I can come in and do a little drawing. I can say that this needs to have a hatch that's placed right here. Maybe put some little arrows indicating that I need to make an opening for the thrusters in order for those to work appropriately. Of course, I can come in, drop in some annotations and stuff like this. Add hatch opening and thruster openings. Something like that, right? Okay, cool deal. Enough said. I'll go ahead and I'll just publish this out if we wanted to 3D Swim community. I could also save a screenshot and shoot an email or something like that, but you can publish it to your work community pretty readily like that. And I could even notify whoever needs to make that change. So that's all built-in capabilities that you get with the 3DEXPERIENCE platform. All right, so what I'm going to do next, I'm going to flip back into xShape, and I'm going to make those changes that we talked about. And the first thing I want to point out here is that I've placed in what's called an ordered geometric set. And within there, I've placed a sketch that matches up and has been converted from the outline of the hatch. So that kind of gives me something that I can shoot for whenever I'm aligning this thing up, right? I'm going to go ahead and hide these sketches, by the way. We don't really need those anymore. And then we'll jump right back into our subdivisional modeling environment. That's just a double click away, by the way. You just kind of double click right in there. And what we've got going on here, I might want to add some additional vertices and faces that we can work with. So I can just select these faces. And from here, we can do what's called a subdivide faces command. And this gives me additional entities that we can work with. Or at least, yep, there we go. It's processing for a second. So from here, what I can do is, in this case, I'm just going to come in and I'll select those faces and delete them. And what we're doing basically, instead of working with a solid from here, I'm kind of working with some actual surface modeling. Now here's another one of those really cool techniques that we can use to mask select entities. I'm just going to select with a double click. And what this is going to allow me to do is it'll automatically select all of the open loop that I'm working with. And in our case, what we're interested in doing is matching up those entities that we have selected. We want to match that up with the sketch that I've created from the hatch. So I'll select both of them and take a look at what we can do from here. We can do an align to curve command, and it's pretty much magic, but it's going to snap into position perfectly for us. And that is hands down my favorite enhancement that they've made this year. The ability to just snap to those entities is super cool. Now, one of the things you might be wondering, well, you know, how do you add back the faces that you were working with? And I'll go ahead and demonstrate how to do that really quickly as well. Basically, I'll just double click to select that open loop, and then we can add back those faces from the context toolbar. So that gives me my watertight solid again. And of course, in this case, I need to crease those edges. This will make it look a lot nicer. We'll go ahead and crease those up. And there we go. That looks pretty good, I think, and it's kind of a perfect little opening that we can use. You know, once we kick this back over to Solidworks, they can add out whatever information they need to place in that. Now, similar to working with a style spline, we have the ability to turn something on that shows like the underlying cage that's driving the surfaces that we have. And this allows us to very easily see anything that might be out of alignment. For instance, these bottom vertices here, I can align them up by just making a pick in succession. I can kind of like pick those two outer areas and then make the internal picks here. And what I can do is align vertices to each other. And this just snaps them into one lined up little area for me. So this makes it look really nice. I'm going to transition into a side view now, and we can see that some of the frontmost faces are just not necessarily lined up. They don't really look great from this orientation. So very similarly, I can just do a selection of all of these faces here. So I'll go ahead and pick those two faces. Those are the two that I kind of want to line up, and then make my additional selections. And really similar to using like your Quick Mates toolbar in SolidWorks, I can just do an align coincident. And these line up to where they're all located on the same plane. So if I switch back to where I'm in more of that side view again, I can really see that they're now perfectly lined up for me. Now you may be wondering, how do you maintain that alignment if you want to make an adjustment to one of the vertices? And that's a great question. And one of the things you can do here is you can actually drag, let me drag the robot itself onto one of those faces. So I'll select the robot, pull it onto that face here, and it's going to orient itself to where it's normal to that face. So now if I move this around, it's going to maintain its orientation, and I don't have to worry about throwing off anything anymore. So I'll kind of leave that somewhere in that area. But that's a really useful tool that you can use. So I'll go ahead and I'll hop out of this type of orientation where we're showing the cage points. I'm just going to show the surface again, and I'm actually going to hop out of the subdivision feature that we were working inside of. So of course what it did, it just knitted everything together. It's now a full watertight solid. And if you remember, whenever we flipped over into SolidWorks previously, we needed to add those cutouts for the thruster bodies, right? Well, I'm not going to model those up from scratch. I've modeled those up previously, and just to kind of meet the time constraints for this webinar, I'm going to show you guys what that looks like. All right, so I'm going to jump into another xShape application that I have running here, and this is the completed out body, right? All I did, I came back in here, did the same steps, and then I just added in the information here for where those thrusters would be located. And the reason I want to show this to you guys is because it's really pretty cool how we do it, and it's really functional as well. So I'm going to go ahead, I'm going to show the bodies that we used to subtract and create those two cavities. And notice how both of those bodies are in their own ordered geometric set. And what that allows us to do is that placing them in an ordered geometric set breaks the dependency upon these bodies. It breaks that dependency between that and any other feature. So there's no longer any other type of chronological solve order or anything going on in this part. And where that really comes in and is beneficial is if I want to make an adjustment, let's say to this vertical thruster, for instance. If I want to make an adjustment to that, I can jump in and I can still see where it's positioned relative to the horizontal thruster, which is happening further down in the feature manager design tree, if you will, for those of you who are SolidWorks users. So this is really powerful stuff because I can then come in and make whatever other adjustments I might need, and I can see how it's going to react relative to that subsequent feature. So this is super powerful stuff. It's called an ordered geometric set. Of course, this is going to go ahead and calculate and update and all of that good stuff. Once that's finished, you can use a combined tool, and basically all you're telling it is, hey, I want to take this body and I want to subtract away that horizontal and vertical thruster body from it. So really, really powerful tools that you can use. And of course, then you can kick this back over to SolidWorks if you want to make additional modifications, or it's a watertight solid, so you can do anything that you normally would be able to do inside of SolidWorks. You can shell it out, use a master model technique, and split this up into different entities and things of that nature. But I hope you guys have enjoyed this and just really seen how powerful this application is and how easy it is to integrate and to learn. You can pick up on how to do this stuff in really a couple of hours and do the basics. It's really that simple and intuitive. The other thing that I like about xShape is that it's just super fast. So as you can see, I modeled up that initial body shape of the Nemo submersible, and what was that? This has been like 25 minutes or something. And then I think the other big benefit here is that it's integrated into the 3DEXPERIENCE platform, which allows us to very easily share that with our existing SolidWorks users and incorporate it into our workflows. So I hope you guys have enjoyed. Thank you all so much for attending. Give us a shout if you're interested in giving xShape a try.